Hey all, this is Justin. I'm the developer for Mutagen, which is a C-sharp library for analyzing and manipulating Bethesda mods. This video is kind of going to go over some of the basics of the testing suite and the how you decode new records and add them to the system. This is kind of what I'm heavily doing now since Oblivion's parsed and Skyrim's kind of getting there. This is a good time to kind of document the procedure just for, I guess, future individuals that are interested. I imagine I'll probably parse all the games that Bethesda has to offer now, but maybe I won't, or maybe, new games will come out. But either way, hopefully this is somewhat informative and interesting for anybody that cares. So yeah, this is Mutagen. We're looking at Visual Studio, which used to code C#. I've already cloned the repo. I'm not going to go into that. And I've opened up the solution. Here are the projects that the Mutagen solution has. This is the one that you guys download if you're going to use it for your own application. But these are all kind of the ones that it relies on. So core is kind of just all the fundamentals, like, it's got the record type and form key and all the things that you guys are familiar with. But then also all the internal bits. And then there's Oblivion and Skyrim, which are the libraries that just contain kind of all the auto-generated records. And they're kind of separated into their own library just to kind of keep things clean. If someone really only wanted to implement Oblivion logic, they could opt to not import everything. And then for me, if I'm developing a specific game, I don't have to always generate for all the games, and I can kind of like unload certain ones that I don't care about. So maybe I don't care about Oblivion currently. But yeah, so here are the auto-generated records, which we're going to get into. You can see I've parsed, or at least defined most of them. Let's take a look at, I guess, armor. Here's the definition for the armor. This file here is the driver XML file for the base library called Loqui, which is just a library I wrote for auto-generation. It's mainly only used for Mutagen, but I felt like I'd separate it just in case somebody else wanted to use it. So yeah, this is the definition file. If I was to auto-generate the records, this comes out the other end. This is pretty messy, but since it's auto-generated and no one's going to be looking at it, it doesn't matter too much. This is the actual armor class that got generated. Here's all the fields and members. You can see it implements the armor interface, which is defined over here. Here's the getter interface, yada yada yada. So all the bits that go into the armor record definition are generated here for me based off of this functionality. So all the instructions for how to parse it from binary, or print it to string, or copy from one armor record to another record is all contained in this code here. And I only have to write and kind of generate off of this file here. So before we kind of get into the generation bits, I'd like to kind of touch on the testing sort of suite, since that's kind of closely tied together. So this is the testing project, and then this is the unit test project. Obviously the unit tests are in here, but this is for kind of the test battery. They're not unit tests because they're kind of long running. So what are the things that we typically do? Well, we're going to do pass-through tests, which is basically Mutagen is going to import Skyrim or import Oblivion, re-export it to a new file, and then do a comparison with the original to make sure that they match up byte to byte. And that's just kind of a cursory first pass on a kind of, okay, generally we're correct. Obviously there might be a few bugs here or there, but for the most part it's able to pass through a mod and have it match byte to byte. Let's go for real quick. These are the testing settings files, which actually doesn't come with the repository. It's get ignored, so you have to kind of provide your own file because you have your own paths. You're going to have different settings that you want to test for you, and I don't want to have this persisted in the repo. So this will be provided somewhere else, probably some gist somewhere, but this is my file. So here I'm going to be testing or reusing my caches, which we'll talk about in a second, testing the normal pass-through. That's kind of the armor record normal, and then we're going to test the binary overlay system, which is the kind of the read-only, very fast, lightweight system that Mutagen also offers for just reading. We're going to, well, I guess we'll test Oblivion too. I guess I'll reload this guy. We're going to test Skyrim and Oblivion. These are the mods that I've pointed it to. I'll probably upgrade this to be more robust later, but we're going to not do any of the other tests. We're just going to do the pass-through for normal and binary, or the overlays on these two guys. And if I start running it, should be doing the tests. I guess I just swapped branches earlier, so it's got to rebuild. All right, so while it's doing that, let's talk a little bit about the caches that it does for pass-throughs. So if you go to your temp folder, after running the tests one time, you'll start getting these files here, which are temporary preprocessed files that it uses to actually do the binary comparison. Because you know, for example, Mutagen, it's hard to do a binary comparison on zipped up records. We'd like to do the binary comparison on the unzipped records. So for example, it's going to take the Skyrim ESM and uncompress all the records and, you know, store that version of the file here. We're also then going to align it so that the records come in the ordering that Mutagen defined them. Since the ordering doesn't matter, we're just going to reshuffle them to match what Mutagen is going to export them as, so we don't have to do any crazy stuff. And then we're going to do a little bit of processing stuff, like floats can be stored in multiple ways for the same values, things like that. Very, very minor sort of tweaks on top of that. And then this file is what we then actually do the binary comparison with. So for example, Oblivion just passed its normal pass-through. So Oblivion's processed file matched with the normal export byte to byte exactly. And so then it said that it passed. It also did a pass-through with the binary overlay systems, and those also passed. I think now it's going on to Skyrim, and it's going to do the same thing. So I think right now it's doing the normal export and then doing the processing check on that. You also see some more stuff for Skyrim, because Skyrim has strings files. So you'll see a very, very similar sort of setup for the strings files. This is the processed string files where we just standardize all the indices, and then these are the exports from Skyrim itself, and then it does the comparison on that. So here we see Skyrim, it says mostly passed, but then there's some more data past this certain value, which we'll talk about in a bit. The strings file is passed, and then now it's going to do the binary overlay testing, which I assume will pass, so we'll just stop there. Oh man, I shouldn't have closed that out. Turn off the Oblivion parsing, run it again. So yeah, it said that it had more data past a certain value. So here's HXD, which is the hex editor I typically use. I've opened up these temporary files, which I showed you earlier, the processed one, the normal export, and the binary overlay. So this is the one that we're actually using as quote-unquote the Bible to compare it to, and this is the file that Mutagen has exported. And it's going to tell us that there's some more data past a certain value. All right, so yeah, we had more data past this value. So if we take this value, we go find it. It's here in the normal file, and it's just not here in the normal export. This is the end of the file, which just means that there's more records to parse. That's expected. I'm not done parsing Skyrim, so there's more things to parse. So what's next? Well, I think this is the Footstep record. So I'm going to take the editor ID, kind of pump it into Xedit. It's, you know, created by a huge team of people that make sure that the records are all perfectly parsed. And for me, I'm just kind of cheat sheeting my way through the parsing setup. They've done all the hard work. You know, our parsing is trying to match Xedit as much as possible. We're going to deviate a little bit, which we'll talk about later. But for starting out, we'll just kind of go one-to-one. So I already think I found the footstep file here. So yeah, we're looking at the footsteps next. These are the records that we expect to parse. You can see that the record type is FSTP, which is the record type that's next. All right, so we got footsteps next. So how do we parse them? This is the definition of the footstep and the footstep set, which we're going to be doing today, in the Xedit source code. So if you clone the repo, you'll find a file that's like, I don't know, it has 5 definitions. Yeah, we're going to parse this first. And so we're going to go in here and we're going to go to the Skyrim project. We're going to go to the records. We're going to go to the major records. And you'll notice that I don't have footstep. I have footstep set because some other record referenced it. So I had to make a kind of empty record for it to reference. But we don't have the footstep itself. So we're going to go in and we're actually just going to do an XML file called footstep. Hopefully the typing's not too crazy. I'm just going to copy this from Footstep Sets since it's empty. I'm going to take away the ID and the GUI or GUID or whatever. So yeah, we're going to call this Footstep, and the record type is going to be FSTP. Normally I have a bigger monitor and multiple monitors, so I'm not doing all this bouncing around, but for the video we'll be kind of alt-tabbing a lot. Alright, so I've got this empty Footstep record. It's of type major record. You can see that there's a few other types. I should talk about this first. Microsoft likes to take away my XML schemas a lot, so we're going to re-add those real quick so we get some autocomplete. It's probably one of the more annoying things that it forgets. Alright, so object type. What types have we got? We've got major records, sub-records, group, and mod. Most things are going to be records, or major records, so that's the type that Footstep's going to be. Alright, so we've got an editor ID. This is handled implicitly by inheriting from the base class Skyrim major record, so we don't have to add the editor ID ourselves. Alright, so next we're going to have a form ID, or in Mutagen terms, form link to an impact data set. Its type in the record is going to be data, and this nonsense means this is the major record type that we're going to be pointing to, and then this right here means that it's a required field. Normally I look for CP normal, and then if this is true, that's required. We're going to add this over here. Actually, let's kind of do a half-half. Alright, so this should have autocomplete if you've done it right. We got all this kind of stuff that Mutagen can auto-generate for us. We're interested in the form link, which is a reference to another record, and it hooks into some special systems. So we're going to call this impact data set. And what's the record type? Well, that's data. And what's the, it's going to complain about this too, so if I don't fill this in, it's going to tell me, well, maybe not. Oh yeah, because I think there's some alternate ways to define things. All right, so we're going to go ref name, and we're going to do impact data set, which is a field or record we already have. I think, yeah, impact data set. So this is basically what we're trying to reference, and we just kind of put the actual name, not the record type. And then we're going to go has been set is false. Whenever a record type is defined, by default it's marked as optional, because that's normally if it's got a record type, it's something that can be present or not present, whereas this one says that it's required. So we're going to say, hey, you cannot, maybe I'll rename this later, but basically you're not nullable. You always have to have a value. And so yeah, that's done, that's parsed. And then we also have a string, so we're going to do string name tag, I guess, record type, a name, and this is also required. So alright, so now I would say Footstep is parsed. We have to do one other thing, which is add it to the Skyrim mod object itself. Here's the Skyrim mod definition, and we're going to go footsteps. Boom. Alright, so now we quote unquote are done parsing. We are going to generate the records. So this is using the auto generation systems. It's going to take the definition we just wrote and generate the class itself. So now if we go back to our Solution Explorer Footstep, we now have a Footstep locally generated. You'll notice that the auto generation system created this class and then put it underneath the XML definition. That's just kind of a setup that I found was useful. You can see that all the other guys have that same sort of setup as well. So yeah, Footstep, the generated record, is now here. Here's the class for Footstep. We've got our tag string that we expect and our form link to the impact data set. And it should be quote unquote parsed. If I was to publish a new version of Mutagen, someone would be able to access and create Footstep records. But we want to test correctness, so this is where we bring up our testing suite. Let's just double check everything's good. We're not going to test Oblivion. I guess we'll test both of normal and overlay. This says that we still have more data to parse. That doesn't mean that we did anything wrong. That just means that maybe there's more to parse. So we have parsed now past the Footsteps group properly, so we can call that quote unquote parsed. And now we're going to move to the Footstep Sets, which is a more interesting case. Footstep is about as simple as you can get as far as a record goes. All right, so Footstep Set is a little bit more interesting, and this is kind of why I wanted to make the video, because it's a good pairing of something that's simple with something that not as crazy complex, but has some extra topics that I want to talk about. So Footstep Set, FSTS, we've got 2 records, so again, not too complex, but it is interesting in the sense of we have this XN or XCNT record, which just contains the counts of how many footsteps we have in this set. And so you'll notice that both here in Xedit and in the definition, we've got 5 UN32s in a row in the subrecord. It's required, and all the fields here I think are required as well. So yeah, we're going to have to parse this count thing, and then we're also going to have to parse a list of form links or form IDs or whatever you want to call them. So an array for us, it's going to be a list of form IDs. So yeah, just 2 records to parse. So one thing I'll note is that you'll notice that this is a subrecord. XCNT is a subrecord, and so you might be tempted to say, okay, I'm going to footstep set counts, object type subrecord, record type XCNT. You might do this, and it's not wrong. And we're going to do uint32, can't type. This is our subrecord definition. It is then going to be referenced by the footstep itself. So ref direct is kind of the good way to do it. So we're going to do counts or whatever. Ref type footstep set counts. So if I was to generate this, it would generate the footstep set record, major record. It would also generate a second file in a second class footstep set counts with these fields that this major record had a reference to. So then someone could make a class of this type, fill these in, and put them in the footstep set. One thing you'll notice though is that this set of records is required. So since it's required, while it is kind of a subrecord, it's never not going to be part of the footstep set. So there's never a scenario where footstep set counts won't exist and won't be part of the footstep set. So it'd actually be preferable to have these fields just be part of footstep set. Like there's no reason to have the user have to create a new subclass that has these fields. Just put them in as part of footstep set. So Mutagen comes with a sort of feature that can kind of inline this stuff. So it's called data, mainly because the records that do this sort of pattern are the data records, but this one's actually XNCT, so we're going to say record type XNCT. If you don't put the record type here, it's just going to be defaulted to type data, and we're just going to put these records inside here. So rather than declaring a subrecord that footstep set has, we're going to kind of inline them. Footstep set now will have a member called walk forward sets, run forward sets, all these things, and it will hide away and abstract away the fact that it's stored in the subrecord XNCT. And this only works because XNCT is required. If it's not required, you have to do the other setup because there needs to be the possibility that these fields don't exist on footstep set. So if it's required and is always there, you can kind of do this cheat sheet, which makes the end user's life a little bit easier. So count is done, and we're going to do a list. There's a few ways to define this. If sometimes lists come with a record type per item, so maybe it's like this where every single form link has a data kind of stamp ahead of it, but this here you can kind of see that it's actually just one time on the list, the whole list itself, so it actually goes up here. So there's going to be one data and then followed by a bunch of footsteps, and we can kind of confirm this in the binary as well. You can see the XNCT records here, and we can see the data record is here with a length of 3C, and these are all the footstep form links kind of back to back to back to back to back. So this now is quote unquote parsed. Footstep set is generated. You'll notice that it only has one class because we inlined these records, and so there's just the one class. We've got all the fields that we expect. These counts that I mentioned earlier are kind of inlined, and then we've got footsteps, the list of form links. Cool. Let's do the testing suite and make sure we didn't screw anything up. All right. So we messed something up because the bytes don't match. So this is kind of what you're going to see when something isn't proper. So these sections of bytes don't match the original source file. So this is where we're like, okay, well, we got most of the way there, but something was messed up. So I'm going to go to the processed file. I'm going to go to the area that was messed up, which, I just kind of get from taking one of these ranges. Usually I take like the second or third or whatever. Well, we're just dumb. I did XNCT and it's XCNT. There's no autocomplete for the generation code. Definitely better this time. We got farther. Let's just double check that we didn't screw anything up and we're actually past the group. So here's the footsteps. Write a new group called SMBN. I don't know what that is yet. Probably have to look that up. Both sides were happy with our footstep set. But we're not going to stop here because even though it's parsed, there are some things that we could improve on this format. While this is quote-unquote as close as directly how they're represented in binary, if we go look at the records here, this structure is what you're going to see here. It's not actually the most usable for the end user. And why do I say that? Well, look at this record here. It says, I am the count or the number of footsteps that you can expect in this massive, massive list later. So it says the first 6 things here are the walk forward footsteps. And then the next 6 are the run forward sets. And then the next 6 are the walk forward alternate sets. But there's a few things that can go wrong. If some user wants to get the first walk forward alternate set, they have to add these 2 numbers together, get 12, find the 12th index, and then that's kind of their first walk forward alternate set. So it's kind of clunky to use. Plus, if you're making footstep set records yourself, you're going to fill this list full of things, and now you're in charge as the user, the guy who's making this, you're in charge of setting these counts to make sense. So you just fill this list full of items, and then you're going to have to say, well, I guess the first 4 are walk forward sets, and you have to kind of sync this together. And I don't even know what happens if you don't even put the right total count here. Like if we just put like 2 for all of these values, like what happens here, or the opposite where we put 6, 6, 6, 4, and then we only put 2 items on the list. Is it going to crash Skyrim? I don't know. But my point is that having this record present adds no power to the end user, and all it is, the only reason the user cares about it is when they screw it up. When they screw it up, things go wrong, and when they don't screw it up, it's just an annoyance to have to sync, and it doesn't add to their lives in any way. So what's a way that we could represent these records to where they can still exist on the disk the way they are supposed to exist, but are easier for the user to use? So I would argue this might be a better setup to do. We're not going to actually even have these fields. These fields are derivative. If we were to make 5, instead of 1 massive list of footsteps, 5 lists of footsteps. So we're getting into the custom scenario. Mutagen is very, very good at generating records that parse Bethesda data out of the box. But then it also has customization tools for when we want to come in and make something special, or when Bethesda kind of just doesn't do things in a consistent way, which is pretty often. So yeah, we're going to have instead 5 lists, and we're going to call this one the walk forward sets. We're going to call the list walk forward sets. And maybe we just, actually, the naming's not even that good. Footsteps. Walk forward footsteps. I like that better. All right. So let's take this out. So the user is going to, when they open up the footstep set record, just encounter 5 lists that they can populate with different footsteps. And that's all they have access to and all they care about. If they want to put 5 run forward footsteps, they just add 5 things to this list. If they want to see how many run forward alternate footsteps there are, they just go run forward alternate footsteps.count. They don't need to care that the counts are stored in a different record, and these are actually all just one big list. This is a better way to offer it to the end users in a way that's less error prone. But this isn't the way that Bethesda is parsing them on the disk. So if we generate this and try to do a pass through this is going to fail to parse for many reasons. So we kind of have to go into the custom mode. We're not going to actually even have a record for XCNT, but we still want to trigger some logic when that record occurs. So we've got just custom logic, name the count record, and then we're going to call that XCNT. And so when it runs into this subrecord, we're going to run a custom function that it's going to allow us to write so that we can do some custom parsing. And then these guys, there's not actually even 5 lists. These don't exist in binary. We're kind of making them up for our end users. So we don't actually want them to generate anything for the binary. We're going to fill these ourselves the way we want to fill them, ourselves. So we don't want to generate any sort of binary parsing code related to these lists. And we don't even want to generate a field for the XCNT records. We just want it to process some custom logic. So this is about as custom as you can get. We say don't even do any binary for any of the records we're defining, and just give me some custom code whenever this record is parsed or encountered. So we're going to generate this and see what happens. So if we build, I think it's going to fail. Failed. That's because there's things that it expects that don't exist, which is namely the custom logic. So how do we add that stuff? Well, this file is generated automatically for us, and it is automatically regenerated every single time. And so if we add any code to this code file, it's going to be nuked all the time. But what we can do is just add our own file called Footstep Set, and you'll notice that it's the same name as this. So this class is partial, which in C# means that you can define this class in 2 different places. And so we're going to do that here. This stuff is extra, public partial. So now we've declared a second file that has that we can write code for this class in a different section. So now that it's in this separate file, the auto generation won't step on our toes and replace things all the time. So what are some of the things that it's complaining about? Well, the Footstep Set binary overlay, which is what powers the binary overlay systems, is saying that it doesn't have the list fields that we defined, and that's because we told it to not generate them. So we're going to have to kind of put them over here. We're going to make an internals namespace because the overlays don't actually exist in a public namespace that the users are aware of. It's kind of hidden away from the user and kind of just used internally. While you definitely make use of it and the benefits that it provides, they don't actually ever create a Footstep Set overlay themselves. So if we do public partial class Footstep Set binary overlay, you can see that there's some partial classes that we're going to override. And there's a reason that they're all separate, but I won't go into that. We don't actually need this partial Footstep Set. We're not actually adding anything to the class itself. We're just writing our custom logic bits here. So you can see that there's a partial method that is defined on the other side for us. So we can kind of just say, okay, this is where we're going to write our custom logic. And unfortunately for the overlay, it's not as clean. The overlay is just complaining about these missing fields, which I'm going to kind of come in here and do this. So we do control period to kind of tries to help solve this for me. How about we add those fields, and it's going to add it to the auto-generated side, which we don't actually want it to do, but I just don't want to type all that out. So we go over here and we add these read-only lists. I'm going to make this full screen that it's expecting. So now things should build, but obviously it's not going to work because we've got a bunch of exceptions that we're throwing. But this is kind of the boilerplate for where we're going to put our custom code. All right, so this is going to trigger when we run into the XCNT record. And we're going to want to parse the counts, find the data record that we expect to be next, and then parse all the things on this one massive list and put them in the appropriate sublists. And then maybe we can do some double checking that these counts add up and make sense, and throw an exception if the total of these numbers don't add to the amount over here. But all right, so how do we do that? Well, we can go frame. Actually, let's do this. Yeah. Subframe. So we're getting into the internals of Mutagen. If someone wanted to write low-level stuff and not use the auto-generated records, this might be more of what they'd be coding like. This might be improved over time because it's for now internal, but maybe later someone prefers to parse in this fashion, so maybe it'll be more robust and user-friendly later. So we're going to do read subrecord frame. So this is going to read the subrecord header data as well as the content and put it into a special struct. And we want it to be so this is a class that just has all the record types that we know about, and this is auto-generated for us, again, by the auto-generation library, so that we can just write neat stuff like this. So we're going to read a subrecord frame, including the header and the content off the stream, and double check that it's the type XCNT. If it's not, that's going to throw an exception internally. So we expect it to be 5 items of length 4 each. These are uint32s, which is 4 each times 5, 20. So if it's not length 20, something's messed up. So yeah, if we check the length and it's not 20, we're going to yell about it. So yeah, I'm instead parsing the just the header here instead of the header and the content, and then I'm just checking that the content length is 20. These structs, by the way, are fed special metadata that align based on the game that we're parsing for. So this knows that it's parsing Skyrim records and knows where the content length will be, how long it is. For the more complex ones like group and major record, they're of different lengths when it comes to like Oblivion versus Skyrim. So this kind of just encapsulates all that logic away so that I can't mess it up. Again, we need to get these counts. So walk forward sets. Actually, let's do uint32, and we're going to do this feature called checked, which is going to check for overflow. In case it happened to be a negative number, we would yell about it. So this is going to throw an exception if this was negative, because we read in a uint32, or sorry, not if it was negative, if it was just like massively large and too large for an integer to hold, it would throw. So if it's like a massive uint, we're going to yell about it. So we're going to parse all the counts. We have parsed the CNT header. We've read that in. We've also read in the 5 values that come after it. And so now we expect it to be at the data subrecord. We are going to double check that. We're going to say that, again, the definition says that this is required. So we can say that we expect it to always be there. And if not, that is a problem, which makes sense. If we don't find, if it doesn't read in another subrecord and it's not of type, or it's not of type data, we're going to throw an exception here. So at this point we should know that we're kind of at the first footstep. So we're going to do a confirmation of length, so kind of similar to this. All right, so we got a kind of sum here. It's probably a better way to do it, but I'm not going to waste your time. So if the sum is, those are all going to be 4. So form IDs are 4 in length, so we have this many form ID count times 4 should equal the content length of the data header. If that, if these numbers don't match up with the total amount of things we have here, then that's a problem. And I think what's interesting actually is that I generated this record earlier, and now I'm using the IntelliSense from the record I generated earlier to write this stuff. So this AutoSense or IntelliSense that I'm getting right now is the same IntelliSense you guys get when you use the library. It's just a little bit slower because it's actually dealing with all the auto-generated records rather than the compiled DLL. Okay, so now I would say this is parsed. We parsed the X count and confirmed length correctness. We've parsed the data header, confirmed length correctness, and now we just need to write things. So now we've written out when we're writing, we've written out our XCNT record. Let's make a little cheat thing here. Write list of. So this is a basically another function that we're kind of inlining here. We could put it alongside here, but we're just kind of putting it here instead. So this is going to be how we write the list out, and we're just going to do this 5 times again. And we need the writer, which I guess we don't actually have to write because we can cheat and do this. It knows that the writer is this guy and brings it into the lambda so that it's happy about it. All right, so we write the X count, we write the data, and write all the form keys for the data, and now this should be good to go. One thing I will say is that binary overlays are picky about how many times you access these fields. So these lists are actually have the potential to be parsed twice because I'm accessing them once here and I'm accessing them once here. So sometimes, you know, we can do this if we're being super hyper optimized, and do this kind of thing where we retrieve the list once from the item, which means that it just gets parsed once, and then we're going to reuse that list to do all this stuff. I'll probably do this for the official code, but I'm not going to do that here. So anyways, this is the writer side of our custom functionality. And then we'll just skip the overlay for now. If you're interested in how to implement this overlay side, you can kind of just look at the official code. So we're going to go try and test our setup again. And we're going to turn off overlays because we know it's not going to work in our current setup. And you know, it's a custom snippet, so I wouldn't be surprised if we mess something up and something either throws an exception or doesn't align anymore. But you know, doing this once for us means that nobody else has to do this nonsense. No one else has to deal with the fact that there's multiple records that can be misaligned and all that stuff. We're doing it once ourselves here, getting rid of the headache and exposing something nice for the end users. And hopefully it works the first time. And we did it properly, I think. This length is past our group that we just parsed, the footsteps. So now this custom code is done. We successfully improved the footstep set so that it just has 5 lists, and the count side subrecord is abstracted away from the users. What I like to do is run the generation code one more time because it's going to put the footstep set custom class that we just wrote underneath the footstep XML, and that's kind of the final resting place for it. Parsed, good to go. I'll probably do a few little changes before I actually officially push it to the repo, but generally you should find this commit in the official repo if you go looking a little bit. Obviously these were kind of very simplistic scenarios. There's a lot of little tricks of the trade when using this generation system. Bethesda's got like a lot of different types of records, and a lot of them don't agree. Yeah, there's no funny business. It's just 5 lists, and that's that. And that's, for me, I think easier for the users to use from my perspective. There's less chance of desyncs, or no one's going to come on and be like, why is my footsteps crashing Skyrim? Because these guys can never get out of sync anymore. They can't screw it up. So yeah, if it doesn't ever reduce the amount of things that someone can do with the library, then I like doing little simplifications like this. There's never going to be a situation where someone's going to want to set this to 7 for no good reason. That's just wrong. It's not adding power to the user. It's just plain up wrong. So abstracting this away, I think, is a positive benefit. So yeah, that's kind of the generation systems. Obviously, with these setups, it took me a long time because I'm talking about it, but like I would have banged these out in 20 minutes or less, and then moved on to some other records after that. The hard part comes when something comes up that the auto generation systems can't handle. There's a lot of curveballs that come out, and then that's when the actual development happens, where you have to modify then the code generation code to generate these records with a new concept that isn't already built in. But most of that's already done. I've done the hard work. Most of the things that you're going to experience and come up with in a Bethesda mod file will be handleable with the systems involved here. Maybe you're not aware of all the tricks and tips and stuff like that, but they're going to exist somewhere in some other record, some little clever way to handle certain scenarios. So yeah, that's the generation systems. Hopefully it's, I don't know, if you guys are just randomly interested in the concepts, hopefully it helped you guys out. If you happen to be helping me parse something in the future, hopefully this is a good tutorial for you guys. So yeah, thanks for watching, and I'll talk to you guys later.